Stay happy learning at your service. Yes, today we have another set of fun-filled learning activities that will be presented by different groups. We are the group 1 and we will be the first presenter. But before we start, I have a little trivia for you. Did you know that the equal sign was first used in 1557 by a Welsh physician, Robert Ricord, in his work The Whetstone of Wit? Ricord used two parallel lines to represent equality because he believed they were the most equal things in existence. We are now done with the trivia, so let's get started. The problem we are gonna discuss will be about the instantaneous velocity. The instantaneous velocity of an object is the limit of the average velocity as the elapsed time approaches zero. To get this, we need to solve the derivative of distance, or we will use the variable s with respect to time, or t, which can be written as the derivative of position with respect to time is equal to the instantaneous velocity. And now for the problem. A car drives down a ramp with a position at a time given by s of t is equal to 40 squared plus 48t plus 36. We have here different questions, which are A. What is the formula to find the instantaneous velocity of the car? Question B. At t is equal to 20 seconds, what is the instantaneous velocity of the car? C. What is the starting instantaneous velocity of the car? And D. What is the instantaneous acceleration of the car over the whole ramp? We also have a bonus question, but we will try to answer that later. Now, let us solve the problem. For question A, we are looking for the formula of the instantaneous velocity. Remember that I gave you a formula a while ago, which is the derivative of position with respect to time is equal to the instantaneous velocity. We just need to substitute the given equation. S of t is equal to 4t squared plus 48t plus 36. Then perform the formula. The derivative of s of t is equal to the derivative of 4t squared, which is 8t, plus the derivative of 48t, which is 48, and the derivative of 36 is 0. So our instantaneous velocity is equals to 8t plus 48. Now for the question B, we are looking for the instantaneous velocity of the car if the time is equals to 20 seconds. In this question, we are using the formula we solved in question A. So v of t equals 8t plus 48. Simply substitute the value of time. Our velocity will be 8 multiplied by 20 plus 48. Then 8 times 20 is equals to 160 plus 48, which will give us 208 as the final answer. Therefore, our instantaneous velocity with respect to 20 seconds is equals to 208 meters per second. To answer question C, we are going to use the same method or formula we used in solving for question B. In this question, we are looking for the starting instantaneous velocity of the car. We are going to use 0 second as the state that the car is on the starting point. We just have to substitute. So our velocity is equal to 8 multiplied by 0 plus 48. 8 times 0 is equals to 0. So 0 plus 48 is simply 48. Therefore, our starting instantaneous velocity is equal to 48 meters per second. Now for the bonus question, if it is said to be finished at minimum of 30 seconds, how long is the ramp? We will give 3 minutes to figure it on your own. solving this problem. To solve this problem, simply use the given equation for s of t, which is 40 squared plus 48t plus 36, then use timestamp 0 and 30 seconds as stated. So for the starting point, just simply substitute the value of time, which is 0. That will be 4 multiplied by 0 squared plus 48 times 0 plus 36. The final answer will be 36. And now for the end of the ramp, we will again use the given equation, then once again substitute the value of t, which is 30. That will be 4 multiplied by 30 squared plus 48 times 30 plus 36. 4 multiplied by 30 squared is equal to 3,600, then 48 times 30 is 1,440 plus 36. The final answer will be 5,076. Now, all you need is to subtract s of 0 to s of 30 to get the length of the ramp. That will be s is equal to 5,076 minus 36. The answer is 5,040. Therefore, the length of our ramp is equal to 5,040 meters. Quite unrealistic for a ramp, right? We are now done solving the problem, so it is now your turn to try by answering the quiz. We will give you 5 minutes to answer the short quiz we prepared. You will be answering 3 quizzes and the link will be sent in the chat box as soon as this slide was presented. Good luck! time's up. And that concludes our presentation. Again, we are the Group 1. Thank you for listening.